Hi, everyone. I hope that you are well. My name is Professor Andrew Timming, and I want to extend a welcome to you for joining me in this lecture series. This is Chapter 3, Lecture 2, corresponding to the textbook Applied Statistics, Business and Management Research. In the previous lecture, you will recall that we primarily focused on the three measures of central tendency, these being the mean, or the arithmetic average, the median, which is the exact center in a distribution of scores, and the mode. These are what I've called inward-looking descriptive statistics for each variable. In this lecture, we will be focusing on the outward-looking statistics. So these include the range, which is a very basic and simple way of measuring spread or dispersion in a group of scores, in a distribution of scores, as well as the standard deviation, which is a standardized measure of the extent to which a set of scores is spread around the mean. So the previous lecture on measures of central tendency, I think, was reasonably easy to comprehend and understand because most people are aware of what the mean is and what it means, how to interpret it, but far fewer people are aware of the concept of the standard deviation and the concept of variability around a distribution seems to be a bit harder to grasp. So I will take my time in explaining this concept, and I hope by the end of this lecture you will be able to understand what I mean by a measure of dispersion, and in particular you'll have an understanding of what I mean when I refer to a standard deviation. All right, without further ado, how about we begin this lecture? Here you can see the textbook that we're using in this lecture series. It's called Applied Statistics, Business and Management Research, published by Sage. You're welcome to purchase this textbook if you'd like. If you would prefer not to purchase it, that is okay by me as well. You are welcome to check out your local library, particularly a university library will likely have this title, and if it doesn't, you can request that they order this title. So let's move on and get into the core of what we mean to talk about in this lecture. So as you recall, in the previous lecture, we talked about measures of central tendency. And I describe measures of central tendency as inward-looking statistics, right? They sort of look inside a particular variable, towards the middle. In this lecture, we will be focusing on measures of dispersion, and I've described these as outward-looking statistics. So they start from the middle, and then they move out towards the extremes, towards the more extreme scores. Now, the simplest measure of dispersion is what we refer to as the range. It is extremely simple. It is easy to calculate and easy to comprehend. So the range is defined as the difference between the highest, the very highest, and the very lowest score in a distribution. And the range is calculated by taking the highest score and simply subtracting it from the lowest score. So if you think back to the previous lecture where we talked about the median, and when I asked you to calculate the median, what you had to do was to set up the distribution of scores from the very lowest to the very highest, and then find the exact center in that distribution. You can use the same setup to calculate the range. So if you've set up your scores from the lowest score in a distribution to the highest, then you simply take each score at the extremes of the distribution and subtract the highest score from the lowest score. So you take the highest score in a distribution of scores, whatever that number is, and you subtract it from the lowest score in a distribution of scores, whatever that number is, and you will end up with the range. So let's take a simple example of how to calculate the range in a distribution of scores. You'll recall from the previous lecture that we used a series of examples around 25 students who've taken an applied statistics course, and we've looked at the grades that they received at the end of the semester. And you can see the 25 numbers in front of you. These are not reported from lowest to highest, so if you'd like, you can go back and either review what you did in the previous lecture where you already listed these out from lowest score to highest score. But you don't necessarily have to do that because this is a pretty small sample. There are only 25 numbers here. Obviously, if we were dealing with a bigger data set with 100 or 200 or 2,000 or more numbers, it would take a very long time to rank order from lowest to highest, in which case we would probably just ask SPSS to calculate the range for us. But given the fact that there are only 25 numbers here, I think you can just sort of scan through these numbers and see if you can identify the lowest number and the highest number. So I'm looking through here and the highest number clearly jumps out at me, and that would be a 100. So one of the students got 100% on his or her exam at the end of the semester. Going through the scores, it appears the lowest number would be the 48%. So you can see that one of the students got a 48, which is a fail. It's unfortunate, but it does happen. So now we've identified the highest number and the lowest number. In order to calculate the range, as I said, it's very simple. You simply take the highest number, 100, and you subtract it from the lowest number, which is 48. So take a moment to calculate that score, and let's see if you get it right. Okay, if you calculated the range correctly, remember this is 100 minus 48, then you get a score of 52. So for this distribution of scores, for the 25 scores that we're looking at, the range is 52. Now the range, because it's such a simple statistic, it's not terribly useful and it's not used very frequently. In many ways, it's similar to the mode when we talk about measures of central tendency. Most data scientists or statisticians don't pay much attention to the mode or, in this case, the range. However, if we're measuring dispersion, measures of dispersion, the standard deviation is a very, very common measure. And the reason it's common is that this statistic, the standard deviation, is used to calculate the results of other statistical tests that we will be learning throughout this course. So it is very important that you understand what I mean when I talk about a standard deviation. And as I said before, this is slightly more complicated than the concept of the mean, right? Most people intuitively understand what the mean is, but it's a bit of a mental stretch to understand what we mean by the standard deviation. So we define the standard deviation here as the average variability or the average spread in a distribution of scores. So this is what I mean when I say it's an outward looking statistic. It starts at the mean and it asks, relative to the mean, how far away is every other score in that distribution. So if every other score is closely clustered around the mean, in other words, there's not much variability or spread, then you will have a low standard deviation. But if the scores are far from the mean, either to the right or to the left of the mean, then you will have a higher standard deviation. So as with the median and the mean, the standard deviation is only relevant to ordinal or scale level variables. And the reason is that the concept of the standard deviation only makes sense when your distribution of scores are hierarchical, that is to say, when they can be rank ordered from lowest to highest. So if you have a nominal variable that you're using, it would be meaningless to calculate the standard deviation because the standard deviation is not applicable to nominal level variables. So remember, whereas the mean defines the most typical case, the most average case, the standard deviation says something important about how far the rest of the scores are spread out around the mean. So in effect, what the standard deviation is measuring is the extent of variability around the mean. So the higher standard deviation that you calculate, the higher the standard deviation, the greater the spread or variability of scores around the mean. And similarly, the lower the standard deviation, the lower the spread or variability around the mean. Now, the mean is a reasonably simple calculation. To calculate the mean, you simply add up every score and you divide by the total number of scores in that distribution. So it's pretty simple arithmetic. To calculate the standard deviation, it is considerably more involved and complex. And I've given you the equation here on this screen. Now, as I've said before, when you're dealing with large data sets, with 2,000 or more respondents in them, as will be the case in this course, the Workplace Employment Relations Survey of Employees and Survey of Organizations, both of these are very, very large data sets. So we would never even dream of using this equation to calculate any of those scores by hand because it would take so long to do it. Instead of calculating them by hand, we instead will ask SPSS to calculate the standard deviation for us. But I think it is good practice as a emerging data scientist to calculate some of these statistics by hand. And I've given you the equation here. If you go back to the textbook, you'll see a step-by-step set of instructions on how to calculate the standard deviation by hand. So what I'd like you to do is to take those 25 scores from the previous slide, the ones that we've been using so far, and to use those scores to calculate the standard deviation, right? So don't be too intimidated by the equation that is in front of you because I explain what it is using narrative words below it. So to calculate the standard deviation, remember this is only for an ordinal or a scale level variable, and in our case, the distribution of scores is a scale level variable. You simply take the square root of the summation of each score squared, right? So you want to take each of the 25 scores, square them and add them up, divided by the total number of cases. So the total number of cases is 25, and then you subtract the mean squared. So you've already calculated the mean in the previous lecture. You simply take that number and then you square it, and this will give you the standard deviation. Okay, so what I would like you to do now is to pause this lecture and calculate the standard deviation by hand for the 25 scores that we've been looking at thus far in the lecture. So I've repeated the 25 scores here. Remember, we've already calculated the range, which was 52. This was based on a low score of 48 and a high score of 100. And what I'd like you to do now is to, perhaps in groups if you're around others, or if you're not, you can do this individually. I'd like you to take the equation from the previous slide and calculate the standard deviation using these 25 scores. And we will look at the results in the next slide, which is the final slide in this lecture. So press pause for a moment now and see what you can do in terms of calculating the standard deviation for this distribution of scores. So solving for this equation, which again appears at first glance to be quite complex, is actually as simple as simply filling in the blanks. So let's take what we know. We know that n equals 25. N is the number of cases in our sample. We know that there are 25 students. So we can clearly put n equals 25. We know that the mean is 78.4, and if we take 78.4 squared, we get 6,146.56. So we can already plug in the mean squared. The next thing we need to do is simply to take all 25 of those scores, square each one of them, and then add up each one of those scores. So I've done that for you here. You're welcome to double check my arithmetic if you'd like, but adding each score squared up gives you a total of 156,720. So with those three numbers, you can then simply plug into the standard deviation equation. So then we have the standard deviation is the square root of 156,720 divided by 25, and then subtract 6146.56. And if you take that calculation to its conclusion, then you get a standard deviation here of 11.06. So 11.06 is the standard deviation for the 25 scores that we analyzed here. And this 11.06 tells you something about the extent to which the scores are spread around the mean. Okay, thank you very much for bearing with me. And again, I would encourage you to try and do this arithmetic yourself. Okay, and there you have it. You've reached the end of this lecture. This is the second lecture corresponding to chapter 3 of the textbook. And in this lecture, we have examined the concept of measures of dispersion. And you'll recall we spent a little bit of time looking at the range as a very simple and basic measure of dispersion, and considerably more time looking at the standard deviation as a significantly more important and more useful measure of dispersion. If you don't fully understand what we mean by the standard deviation just yet, don't worry too much, because in the following lecture, in the next lecture, we're going to examine how to interpret and understand the standard deviation more clearly. But for now, it's important that you understand A, how to calculate the standard deviation. In other words, what are the elements of the calculation, and B, that the standard deviation is a measure of the spread or the variability of scores associated with either an ordinal or a scale level variable. So thank you very much again for bearing with me. I appreciate your time, and I will look forward to seeing you in the next lecture. Thanks, everyone. Have a good day.